Egil runs a family company with 2 vessels and 36 employees, and you have ordered more vessels.
Not now.
Huh?
Not now.
No, but you are an optimistic guy. And you've been doing this in your family company, and you're going to talk a little bit to us about one particular vessel.
Yes.
But before that, I know that you also have a keen interest in working as a volunteer in the Norwegian Trekking Association, which has a lot of cabins all over Norway for people who want to go, especially in the mountains. And there is one cabin that has also influenced your thoughts as a fisherman.
Absolutely. I'm in Tåkeheimen, which are said to be the most difficult hut to go to in Norway. It's placed directly beside Svartisen, the second largest glacier in Norway. And the impact on the glacier the last 20 years is ridiculous. It's, you can't imagine what is happening. In front of the hut, when it was built in mid-90s, the ice was just in front of it. When they was building it, they had digged their cooler into the ice, and it was moving around 150 meters under the building time, together with the ice, which are like a slow river. And at the moment, there is around 100 height meters down to the glacier from the hut.
So that has opened your eyes for doing something with the climate.
Yeah, I think there is happening something. We are also, of course, as captain of the sea, I also seen it.
So, Captain, the floor is yours.
Thank you. Let's see if I have a... Yes, at first, I have a picture from my office. This is taken directly from my office window. And back there, you can see a part of the glacier. In the end of the fjord there, on top of the mountains, you see the glacier. The Sørum Holding is a family company. I'm the 3rd generation, and I have the Ford with me. Very proud of that. Yes, we are operating new building a big coastal vessel, which was delivered in 2021. We was also taking what we could do of taking care of to take down the carbon footprint from it, to take down the energy consumption in what is possible into that size of hull. And then last year, we took delivery of this ship, where we, the new building was coming home the 11th of August, 23. We had the naming ceremony at the 12th of August back home. She's 80 meters long, 16.2 meters beam, and has a 12 fish hulls with total 2,500 cubic meters of RSV tanks. Yes, it's a very special ship. I will go through a lot of the things which we was doing. We had a project philosophy when we was starting the project. We have been working a long time with it. We have had several projects together with SINTEF, and also with the ship's designers, Skipsteknisk in Ålesund. What can we do to reduce carbon footprint while also making a good vessel for crew and owner? Reduce the power consumption, availability of new fuels, reliable technology, politics, what is coming next? That's not something of an issue. Fishery efficiency, fish handling and quality, safe working conditions, and a lot of other issues. It's a large vessel, but there is little free space. This is the LNG tank. You have it here. It's vertical, and back here you have the main engine and gear and these things. As you can see, the LNG tank is a big space in the ship. It goes over the total beam. This cut is in the middle of the ship. So you see equipment. This is the water handling for the fish operation. You have the cooling plants. And up here you have the EX zone for LNG, an EX zone for ammonia. and we also have EX zone for battery pack. There's a lot of issues to take care of when you build this kind of vessels. We have a fish distribution deck, and we have this trawl area and fishing gear area operations. And back here we have the switchboard room, and we have battery room. Yes, the LNG 350 cubic meter vertical tank. It's like a big steel thermos. It's vacuum isolated. It's 225 tons of stainless steel in 2 layers. It's a big cold box in the front of it. Oh, sorry. Which you see here. It's a 2 storage facility full of valves and equipment. It's quite impressive technology inside. Use of LNG reduces carbon footprint with more than 20% compared to diesel. If we can use 50% biogas LPG, the ship operation will be carbon neutral. LNG gives very low NOx and almost no SOx and particle emission. LNG is well proven as fuel for ships. Still, we have had a lot of issues to get it operational. It's very different from diesel. It's much more complicated. The regulatory system is fully developed. That's a big question. It was not fully developed 5 years ago. What about the new stuff, which are much, much more dangerous on board ships? We have ammonia in the RSV plant. It's only 200 kilos, and there is a lot of issues around it. Explosives, gas, special tool, safety to go into the room if you have ammonia leakage, chemical drugs. It's a lot of questions. LNG temperature is, of course, dangerous thing when you're bunkering. It's 140 to 160 minus. If you get it on your body, it's like fleeting steel, the effect on the body. If you have it on your finger, it falls off. If it drops on the steel, normal steel, it breaks like glass. So we have to have stainless steel there, or a water flow to take care of the cold. Bunkering planning is, of course, important. 350 cubic of gas is around the same as 160 cubic meters of MGO. A normal ship, fishing vessel of this size has normally 400 cubic meters of MGO capacity. So we have a dual fuel, and we have a diesel capacity of 300 cubic meters on top of this. Long layups means rising temperature and pressure, requiring consumption of boil-off gas, BOP, and finally bunkering of new coal gas. The temperatures rises slowly. 2 months, and then we have problems with the heat. And we also have to bunker before we stop fishery, before we lay up to have cold. You can't empty the tank. If you empty it, it takes nearly the same cost as a filling of gas to take it down in temperature, and it takes a long time. Yes, LNG bunkering. As you can see, we are here having Bergen LNG on the ship side. It's a small tanker with gas on board. That's very efficient. There's very good part of it. It takes a half an hour to connect, move the vessel and connect the hose. 1 hour bunkering 200 cubic meters, and a half an hour disconnect. So that's very efficient. That's a very good thing. Then we have other things to take down consumption of energy on board. We have a DC main switchboard. And here we have a lot of text. It reduces losses in the electric supply. The easy to charge and use battery pack on 1 megawatt, because the main consumption and the consumption which are varying a lot is on the same side of the current system. our large and main consumers down to 50 kilowatt is placed in DC side, that reduces the loss in frequency conversion with 50%. Electric system without voltage drops common on ships with simpler star delta starters on the large consumers. Side thrusters with frequency drive and fixed bridge propeller especially has much lower power consumption. It's one of the things which have impressed me most. It's very, very big difference from what I've seen before. And we can stay by key using only 300 kilowatts totally to have the ship laid by key. If you had this star delta and full RPM on the propeller, we will have used 800 or 900 kilowatts to stay at key, just to keep the engines going and a little push. Pumps and fans, etc. with frequency conversion can run only at speed needed, reduces power consumption and wear on the equipment. We had a frequency conversion on the seawater pump on our old vessel, and we haven't changed that pump. It has been running for over 20 years without need of change because it runs on a perfect RPM. Yeah, and we also have a DC-based electric winch system. It means that the winch system is fed with DC and then converted to the winches. Resulting savings. Trafo when battery and most consumers is on DC, it simplifies the power handling in the switchboard system, half the trafo size compared to similar ships without DC main drive. This trafo at our ship is now using around 20 kilowatts. Shore power supply at 50 Hz supplied to DC side means ship equipment still on 60 Hz. However, keeping DC side alive all times gives some increased consumption in the shore mode, 20 kilowatts as I said. Additional contributions, hot and cold, heat to power from pyrothermal makes electric power from difference between hot and cold water through piezo electric elements. Cold recovery uses the heating of LNG gas to cool down water in the fish holes. Hull design optimized for economic speed by liter per nautical mile sailed. Rudder hub to reduce propeller drags, superstructure streamlined to reduce air resistance and wind shear. This economic speed of a vessel, when you have the smallest power input to have an optimized speed, is very different from a top speed. And when you have this speed, you have a lot of difference from what you look at for a top speed. And you change the design to do that. Human factor. I think human factor is not seen enough to take down the consumption on a vessel. Most systems require user input to operate. Therefore, it must be visible and intuitive how to reduce power consumption for the crew. You must see what is happening. We have chosen a modern IS system from Norwegian supplier Blue Control. It gives a good overview of consumption and operation of the systems on board, also with trends and stored data. Around 30,000 connections to the system. IS cross connectors are fiber optic. It's quite advanced system and a lot of cables around. But of course, in the wheelhouse, when I'm still handling the propellers, I can see the consumption instantly of each propeller on pumps, on the RSV plant. What I want, I can manage the screen as I want. The ship has fishery efficiency and quality. Fishery efficiency and capacity to take good care of the catch is important for the total power consumption and value of the catch. 12 fish holes with extensive control system. RSV plants, 3 RSV can be run by both in series and in parallel to keep different catches from each other. Also, we can use one plant if we don't need more than one. Another thing, we have recently registered a new company, Halse Energy, which has the goal to produce LPG. Raw material will be waste from meat production, fish farming, and food waste. And we also have this source. It's how we have seen it on earlier screens, how good biogas is in using waste and make energy. It's a very good way to make new energy. So hopefully we can realize this. Politics. At the moment, I doubt that the goals of zero emission can be achieved in 2050 by Norwegian fishing vessels. Ships currently under design and construction are, as far as I can see, only prepared for biodiesel to achieve this goal. There is no realistic that will be available biodiesel for everybody. I've seen some of the speeches before me, but what I hear from DNV is that this is not possible because the rest of the world is also changing to biodiesel. And they will need much more than it's available. Ammonia and hydrogen are requiring much more space on board, and they have a lot of safety issues. As you saw the screen of the ship, how full it is. LNG ships has some easier way to get enough LNG to be climate neutral. Technology and research. I believe in new technology, but we must have evidence that it works. We need a platform to share knowledge and compare solutions to know what works and not. FOF are now underway to start a project for benchmarking of efficiency between new ships. Can AI help us getting the results faster? Thank you.